So in our previous slide we did valence bond theory. So we took many complexes and we tried to find out whether they are high spin complexes, whether they are low spin complexes, the number of unpaired electrons in it, as well as the diamagnetic and the paramagnetic properties. This all valence bond theory could very well explain, the diamagnetic properties, the number of unpaired electrons and everything else. But it had some major limitations. So now let's see what were the limitations of the valence bond theory. The first limitation of the valence bond theory is that it gives us only a qualitative explanation of the complex formation. So valence bond theory, if we talk about the valence bond theory, when we talk about it, the metal ligand bond. The valence bond theory, it considers the metal ligand bond to be purely covalent or purely coordinate, and coordinate is the type of covalent bond, right? So it considers the metal ligand bond to be purely covalent, but we know, at least studying chemistry till now, we know that no bond is purely covalent or purely ionic. Every bond has a percentage ionic character, every bond has a percentage covalent character, even if that percentage is very less. But our valence bond theory, it says that its bond is purely covalent. It does not give us a percentage of the ionic character present in that bond. It does not give us a percentage of the covalent character in that bond. So this is the first limitation of your valence bond theory. Now let's see what are more limitations of the valence bond theory. Valence bond theory, as I said, it is a good theory to explain whether a complex is going to be paramagnetic or whether a complex is going to be diamagnetic based upon the number of unpaired electrons it has. But it cannot explain the variation of the susceptibility of the paramagnetic and the diamagnetic substances with temperature. Now what is susceptibility? Susceptibility is actually a dimensionless quantity which is used to measure the degree of magnetization of a particular substance in an external magnetic field. So paramagnetic and diamagnetic complexes, both of them, their magnetization, it varies with temperature. But that valence bond theory could not explain how it varies with temperature, why it varies with temperature and everything else related to the paramagnetism and the diamagnetism of the coordination complexes. This was the second limitation. Now let's come to the third limitation. The valence bond theory cannot explain the kinetic and the thermodynamic stabilities of the complexes. So this brings us to the question, what are kinetic and thermodynamic stabilities? If a complex is thermodynamically stable against a reagent, that means the complex is not going to react with that reagent. If a complex is kinetically stable with a reagent, that means the complex is going to react with the reagent, but it is going to take a long time. So kinetic stability, it deals with the rate, and the thermodynamic stability, it deals with the spontaneity. So if we take a complex based upon the kinetic stability, we can say either the complex is going to be inert or the complex is going to be labile. So if the complex is inert, that means the complex is not going to react fast with a particular reagent. Okay. So inert and labile you can judge only with a particular reagent. Inert means it's not going to react fast with a particular reagent, and labile means it's going to react fast with a particular reagent. And in thermodynamics, we can say that a complex is perfect or it is imperfect. So a perfect complex is not going to react at all with that particular reagent, whereas an imperfect complex is going to react with that particular reagent. But how much time it is going to take to react with that particular reagent, that depends upon the kinetic stability. So again, valence bond theory does not tell us anything at all about it, whether that complex is kinetically stable or not, or whether that complex is thermodynamically stable or not with a particular reagent. So that is one of its major limitations.